Picture this, you're in the ER. An AI is analyzing your vitals, and it knows there's a 10% chance you're going to crash. What does it do? Does it admit you right this second, or does it send you home for observation? Welcome to this explainer. Today, we're diving into a really groundbreaking new arXiv preprint. It's called Some Large Language Models Exhibit Consistent Risk Attitudes. And honestly, it fundamentally challenges how we think about artificial intelligence.
Right, so it brings us to this incredibly simple but really profound question. When an AI is playing doctor or, flying a drone, does it actually have a built-in personality for risk? See, we usually measure AI by its accuracy. Can it pass the bar exam? Can it correctly identify a disease? But taking a test is one thing. Making a literal life-or-death choice in the real world, that is entirely different. As AIs start making these actual concrete choices, mere accuracy just isn't the whole story anymore.
Okay, so here's our roadmap for today. We'll define the AI risk personality, look at how researchers decouple belief from action, test it out across 3 domains, check out their consistent risk postures, compare AI to human behavior, and finally, look at the future of AI alignment. Let's get right into it. Section 1. The AI risk personality. What actually happens when AI must choose under uncertainty? So when AI enters high-stakes fields, think clinical triage or high finance, it's forced to make irreversible choices. It has to weigh incomplete observations against outcomes that could cause, severe harm or massive financial loss. In psychology, how you handle those high stakes is called your risk attitude. It's this intrinsic filter that dictates whether you lean cautious or aggressive when the pressure is really on. It's not a gap in factual knowledge, it's a core personality trait. And the researchers wanted to know, have these large language models trained on mountains of our data accidentally developed their own risk attitudes? Moving to Section 2, decoupling belief from action, separating perception from the final choice. How do you actually go about testing this? Well, you have to completely separate what the AI thinks from what it ultimately does. It's a 3-step process. Step 1 is taking in the observations. Step 2 is stating the contextual belief out loud, so essentially rating the risk from 0 to 100, say stating there's a 15% chance of failure. And then Step 3 is the categorical action taken. The researchers actually used regression models, which is basically advanced mathematical curve fitting, to map exactly how that Step 2 belief converts into the Step 3 action. Think about it like this. You have 2 doctors. They both look at a chart and recognize a 10% risk of a patient deteriorating, but their actions differ. One admits the patient immediately, while the other decides, let's wait and observe. That difference, that reveals their underlying risk attitudes. By forcing the AI to state its belief before acting, researchers completely isolated its ability to read data from its core risk personality.
Section 3. Testing across 3 domains. The ultimate AI personality test.
To prove this wasn't just some weird fluke of prompt engineering, they tested 6 major models across 3 wildly different arenas. Imagine the AI controlling a drone, having to navigate through high winds and physical obstacles. Or playing doctor, assigning emergency room triage levels based on constantly evolving vital signs. Or acting as a Wall Street trader, allocating a financial portfolio in a really turbulent market. These tasks are structurally completely different: spatial, medical, and financial. But, an AI score doesn't mean much in a total vacuum. So to provide a really rigorous baseline, they established a human benchmark. They ran exactly 100 actual people through the exact same 3 task domains using custom web interfaces. This gives us a solid, real-world human behavioral distribution to compare our AI models against. Section 4. Consistent AI risk postures. A cautious doctor makes a cautious pilot. So, the big question. Do the models actually have consistent personalities? The answer is a resounding yes. The data revealed incredibly high stability. First, they showed intra-task consistency, meaning under the exact same conditions, the AI makes the exact same choice. It's not just guessing randomly, but the real shocker here is the inter-task stability. A model that plays it safe and cautious in the hospital is also, generally speaking, a conservative drone pilot and a cautious investor. This scorecard is just fascinating. Claude's on at 4.5 and Grok 4 consistently ranked as highly cautious. They are essentially the digital equivalent of wearing a belt and suspenders. But on the complete flip side of the spectrum, OpenAI's GPT 5.2 ranked as the most aggressive, showing a much higher risk tolerance no matter what job it was doing. The models consistently preserve their relative risk posture. Section 5. AI versus human behavior. The compression of behavioral diversity. Now, how do these AI personalities stack up against our 100 humans? Are the models mimicking us perfectly? Take a look at the contrast here. We humans possess this beautifully chaotic, broad spectrum of risk-taking. Some of us are extremely cautious, some are totally neutral, and some are highly aggressive. AI models, however, they are compressed into a very narrow, average-seeking band right in the middle. They absolutely do not represent our full spectrum of risk disposition.
So why does this happen? Well, it points directly to how we train them. Techniques like RLHF, reinforcement learning from human feedback, reward models for crowd-pleasing, safe answers. By trying to please everyone and trying to avoid causing any offense, the training process accidentally strips away the extremes. It pushes the AI toward a really bland, institutional consensus. Sure, it makes them predictable, but it also means a vast amount of normal human behavioral diversity is just completely missing from these systems. Section 6. The future of AI alignment. Beyond just factual correctness.
How does this reshape our entire understanding of AI safety and evaluation? There's a really powerful quote from the paper. These systems no longer merely compute probabilities, they choose under uncertainty. Intelligence and risk posture are simply not the same thing. You can have an incredibly smart AI that is a reckless gambler and a highly intelligent model that is overly cautious. We absolutely must audit both before deploying AI in high-stakes environments. We need entirely new benchmarks that test an AI's attitude toward uncertainty, not just its factual accuracy.
I'm going to leave you with this final provocative thought from our explainer today. In our quest to make AI perfectly safe and aligned, are we accidentally engineering away the very human diversity we might actually need? If every single AI makes decisions based on an artificially narrow, averaged-out risk profile, who do we turn to when we actually need a bold innovator or a hyper-conservative guardian? Keep questioning how our digital counterparts are learning to think. Thanks so much for joining me.